And type 1 error and type 2 error. So type 1 error, as you can see here, the type 1 error is the case. Indeed, this is the truth. Truth can be null hypothesis true or null hypothesis false, right? So in truth, null hypothesis true, so which means we fail to reject the null hypothesis. That should be the case, but somehow we can reject the null hypothesis. That's possible because we are collecting sample. Always there is a possibility our evidence is kind of wrong, some kind of very special case, and then we reject null hypothesis even though null hypothesis is true. That error is what we call the type 1 error. And then type 2 error is the case, is the other case. Even though null hypothesis false, it's not true, which means we should be able to reject the null hypothesis, but somehow we cannot collect the evidence, so we fail to reject the null hypothesis. That is again, this is the error. That's what we call the type 2 error. Okay, so this is the right case because a null hypothesis is true, so we fail to reject the null hypothesis. This is the right decision. And then when null hypothesis is false, we should be able to reject the null hypothesis. That's correct. But this is a statistical analysis. There is always the possibility our conclusion can be wrong. So that's what we call this type 1 error and type 2 error. So rejecting the null hypothesis when the true is when it is true, this is a type 1 error or false positive, right? Or the failure to reject the null hypothesis when this is false, then this is a false negative, or type 2 error. So we will try to minimize the chances of the error by collecting the sample. So we can find out what is the chance of type 1 error and type 2 error later, but we will focus on the making a conclusion in this chapter. Consequence of type 1 and type 2 error can be different. So some case we are focusing on trying to reduce type 1 error, even though you have to allow the type 2 error or the vice versa. For example, type 1 error is convicting the innocent defendant. So courts are borne by the defendant, but type 2 error is failing to convict the guilty defendant. So courts are borne by the society. However, our law system is trying to avoid give a punishment to the innocent dependent, even though we have to release the one guilty dependent. I think there is a statement is like even though we release a 10 thief, but we try to avoid the one innocent. We lock down the one innocent dependent. So again, the example can be a lot like the COVID. If you gotta test COVID, there is a type 1 error and type 2 error. Even though you got a real COVID virus, but your test result can be negative. Or you don't have a COVID, but your result can be positive. This is type 1 and type 2 error, same, false positive and false negative. But these two different error has two different consequence, right? So depends on the situation. Type 1 error is more serious. Some cases type 2 error is more serious. So firms are increasingly worried of the type 2 error, falling to the recall the product as soon as the sample evidence begin to indicate the potential problem. So you don't want to release some product that has a problem. You want to recall the product as soon as possible. So that is type 2 error. Even though the product has some problem, you may fail to reject the null hypothesis. Here the null hypothesis is that our product doesn't have a problem, and the alternative hypothesis will be our product has a problem. So when we collect the evidence, you are trying to collect the evidence, there is a significant problem, potential problem of our product. If you have a strong enough evidence, then you can reject with null hypothesis that our product has no problem, and we can say, right, no problem. And null hypothesis, alternative hypothesis is that there is a potential problem. And this is obvious. Can we have the opposite? Null hypothesis can be the problem, and alternative hypothesis no problem at all. But remember what we're trying to do when we collect the sample and then trying to do is to reject the null hypothesis. When we collected, how can we collect the evidence there is no problem, right? So we have to find out the cases of our product has a problem, right? That is if you have enough of that evidence, we will reject the null hypothesis. So you have to think about it, which one should be the null hypothesis, which one should be the alternative hypothesis. Is our effort should be trying to reject the null hypothesis. Probability of type 1 error and type 2 error, usually we call this is alpha. Type 1 error is the alpha, and then type 2 error is a beta, and then there is the name is power. Power is 1 minus beta. So power also can be the sensitivity, and this sensitivity is the word from if you have a chance to discuss about the machine learning or the data analytics, then that sensitivity and specificity will come here, and that is the same as power in statistics. So alpha here is the level of significance. So we will decide the level of significance. So which means is how strong evidence should be strong enough. So we have to set the level of significance. So since we are talking about statistical analysis, so is it strong enough? How strong is the strong enough? So that is the level of significance, and then we have to decide with the alpha. So if you increase alpha, then you are increasing the probability of type 1 error. If you reduce alpha, and then you are trying to reduce type 1 error. But actually these two things is a kind of the trade-off, right? If you try to increase alpha, then actually you are the decreasing beta, but if you decrease alpha, then you are increasing beta. So power of test is the probability of false hypothesis. So which means is the false hypothesis will be rejected. So which one is correct? So power equals to the 1 minus beta. Here beta is the probability that the false probability of the reject or fail to reject given that the null hypothesis is false. So 1 minus beta means this is the probability that reject given that the null hypothesis is false. Okay, larger sample lead to the increased power, which is why the clinical trial often involved thousands of people. So if you increase the sample size, actually you can improve the power. Relationship between beta is both of the small alpha and small beta are desirable because alpha is the type 1 error probability, beta is type 2 error probability. There is a trade-off. I already told you trade-off between alpha and beta. If larger critical value needed to the reduce risk, make it harder to reject the null hypothesis, that increasing the beta. So if you lower the alpha and you are increasing the beta, and then if you reduce the alpha, then you are increasing beta, and vice versa. So only way we can reduce both of them is the increasing the sample size. How are the alpha and beta calculated? Usually alpha is not calculated, it's decided by our decision maker. So level of significance, alpha is not calculated. Instead we choose value based on our willingness. So what is the risk of taking type 1 error? How much? So usually it's a 0.1, 0.01, 0.5. This is tied to the 99% confidence interval, 95% confidence interval, and 90% confidence interval. So exactly the same meaning. Alpha 0.01 is the 90% confidence, and the 0.05 alpha is the 95%, and 0.1 alpha is 90% confidence. Choosing smaller value of alpha means greater concern of the consequence of type 1. So if you choose a smaller one, this is a tighter. Right? And the value of alpha is consequently power on 1 minus beta will, depending on the difference between the true mean. So power is actually the calculated by the true mean. So you cannot just simply calculate it by what is alpha and then what is the situation. You have to know the true means. So it depends on the true means, your beta can be a lot different. So our textbook covers the how to calculate the power or beta here, but I will set it as optional, so you don't have to go over the how to calculate the power here. Decision rule and the critical value. So statistical hypothesis is a statement about the value of population parameters. So parameter can be the mean, proportion, and variance, but we will focus on the mean and proportion here only. The variance part will be also the optional here. Hypothesis test is decision making between the two competing hypotheses, null hypothesis or alternative hypothesis. The decision rule and the critical value. So if we will find the critical value first. So this is like a critical point. This is like the turning point. If our statistical value is smaller than the critical point or greater than critical point, so we will make a decision. So I'm not saying it's a smaller or bigger because it depends on the situation. It can be different. So this null hypothesis state benchmark value will donate with a subscription 0. It's a mu 0 or a pi 0. Okay, this is usually the benchmark, so it's not usually calculated. This is the given numbers. So so far, we talk about a lot of the hypothesis rejecting or kind of things, but we will see the example soon. So once we talk about the example, then you will see what I'm talking about. So null hypothesis testing. Null hypothesis, if the null hypothesis is the mu is greater than the mu 0, again the mu naught or mu 0 is the given number. So this is our sample. So what you can tell is our population mean is greater than certain number. That's a null hypothesis. And then I'm collecting the evidence to reject the null hypothesis, which means I'm trying to collect the evidence. How many times our population means, actually we will estimate this population mean using the sample mean, but we trying to collect to reject the null hypothesis, and the alternative hypothesis will be the mu will be smaller than that certain number. This is a left tail test because since null hypothesis test is something like that, so if we find out mu, this is the mu 0, and if we find that our mu is located here, then this is a significantly far away, then we can say our mean, population mean, is smaller than the mu 0, which is the given number. Otherwise, even though this is a slightly smaller, this is not far enough, then we cannot say our mu is smaller than mu 0. So this is like a left hand side tail. That's why we call this is a left tail test. Right hand side test is if this is the mu 0, and then our mu is located far away from the mu to the bigger side, then we can say, okay, our alternative hypothesis is true. So this is the right hand side tail, right? So that's why it is right tail test. What is the two tail test? Two tail test is the null hypothesis is they are equal or they are not the same. When they are not the same, this can be rejected by the two way. One way is the mu is, okay, so again center is the mu 0. Mu is a lot bigger than the mu 0, or mu is a lot smaller than the mu 0. So we have to consider the both of case. That's why this is a two-tail test. So two-tail test or one-tail test will be the critical point of the probability will be slightly different. So we will talk about that later.